Hello, it's me, and I figure it's about time to tackle Gyroscope's brilliant circle face turning rhombic dodecahedron. So this is a scary looking puzzle because not only is it, well, a face turning rhombic dodecahedron, which does all the things that it does, like jumble, shapeshift, all that good stuff, but you've got circle puzzle here too, so it adds that degree of complexity. So people ask me, how do I come up with algorithms? How do I approach solve of a puzzle that's not really been approached before? So I'm going to go through a little bit on how I do that before I actually start the solve. So I actually haven't had a chance to look at this much, so I figure I'd do this while I'm videotaping it so that you can see the process that I go through. Well, the first thing that I do, and I just want to say that this isn't the original sticker configuration. Gyroscope was kind enough to send me a new sticker supply because the previous ones were kind of peeling. I think I'd stored it for too long. So this is more the standard sticker configuration. I tried to make it match as much this as humanly possible so you can see, well, some of it is not the same unless oh yeah, no, it's fairly the same. So I tried to keep it as consistent as possible. So basically, having come off of the solve of this, I did go through how to approach a lot of these pieces, how to approach the complexity here. Let's do the same thing with this. So the first thing with a puzzle is I try to correlate it with similar puzzles so that I can borrow some of the strategies. And one thing that's known is that when you have a face-turning rhombic dodecahedron, this actually has an equivalence to a platonic solid, which is a hexahedron. And that equivalence, from a functional standpoint, is as an edge-turning hexahedron, edge-turning hexahedral platonic solid, because it's very similar in its functionality. So if this were a side and this were a side here, then I can think of these four as being like edges, edge turners. So that this turn would be like this, and this turn would be like this, and then I can start my jumbling maneuver here, like so, and I can start this jumbling maneuver here, like so. Now what's interesting is this remains stationary each time. So that means I can correlate different pieces, and from that I can gather the kind of movements to expect. That's not going to help in terms of the overall solve, but it will help in terms of what to expect with the motion of this puzzle so I can start designing commutators. The design of a commutator is pretty straightforward. What you do is you take a move, and then you do another move, then you undo it. So like R, U, R-I, U-I. Okay? What I then do is I then look to see if there is a piece that's been isolated. For instance, I see this piece here has been isolated. And I know that I can get out of this by reversing what I just did, U, R, U, I, R, I. Okay, so R, U, R, I, U, I. Now before I reverse it and get it right back, I find that this piece here is isolated. None of this was affected. So I do a middle move where I'll just move this here, boom. Then upon doing that, after doing that middle move, I'll then reverse the original commutator, U, R, U, I, R, I, and then reverse my middle move, bang. So in that way, it'll only affect three pieces. Now, this is just a simple kind of a commutator where you do a commutator, a middle move after you isolate a piece, then undo the commutator and undo the middle move. And the commutator is just two moves and then the reverse of those two moves. So this one to here, this one to here, and this one to here. So my purpose of that is to show how simple it is to design a commutator. And what I do then is I just find out other scenarios all around the puzzle and then I can solve it from there. So too, I'll use this and to see what I can do in terms of moving these puzzles all around. Now I know how to move these guys. I sort of discovered that when I correlated the Rua puzzle to the curvy copter, and stating that these edges here are equivalent to these corners here, so they'll move as such. And these corners here are kind of equivalent to this piece, and that's where it's sort of left off in terms of the strategy. So how can I do a commutator here? Well, I could start over here and do 2R, 2U, 2R, 2U. Okay, now to get it back, I just say 2U, 2R, 2U, 2R. Now the way that I solve this puzzle is I just place the corners in first. But I rather suspect I'm not going to be able to do that with this puzzle, because by moving these in, I'm going to take some of these pieces out. So I may find myself, the way that I solve circle puzzles, and the reason why I like circle puzzles is it's like you're getting two puzzles in one. You've got the middle puzzle, and then after that's solved, you've got the outer shell. It's like a real puzzle, like the real 5x5, where you have the hidden pieces become its own kind of puzzle. So I suspect I'm going to have to solve this first and then the outer shell. But let's see what we can do about how to move maybe pieces around, maybe corner pieces. So let's go to R, to U, to R, to U. Okay, so I'm looking around and I don't see a whole lot of ability to do a middle move. So if I don't see that, maybe I can try to orchestrate something. None of these are affected, but this is. So what if I took this piece and I did a move like this? Boom. Well, if I do this, if I move this down here, now what if I reversed what I just did? So in other words, I'm taking this and I'm going to do a middle move right over here. Now as you can see, I didn't really isolate that piece. So, and these really weren't taken out. These were the only ones that were affected, these guys here. None of these were. So if I move this down here, let's see what happens if I now reverse it and then move this back. To U, to R, to U, to R, and now we're going to move this back. Okay, something that I noticed here is it caused some effects, but I noticed that this piece here is now isolated. Notice everything came back except this piece, this corner piece. So what I'm going to say is now I've isolated a piece, and to do that I did an entire algorithm. To R, to U, to R, to U, and I moved this down, then to U, to R, to U, to R, and I moved it back up. I'm going to say that I now have another uber middle move, so to speak, with this piece isolated. So what I'm going to do is I'm simply going to take this and I'm going to do a move like this. Boom. If I reduce everything that I just did, only this piece and maybe a piece up here will be affected. So I move this here. Let's go ahead and reverse what I just did. So if I were to work backwards, I finished it with that original middle move here. So I'll do another middle move up, start off with a middle move here. And I'll do that commutator again, to R, to U, to R, to U, and then do this other beginning middle move over here, and then finish it up with to U, to R, to U, to R. And I'm going to take this and move this. This is the middle move, so to speak, and move this back. So I built a complexity of an algorithm and then a middle move in between all of it, and then reverse the whole thing. So you can get as complex with your commutator as you want, as long as you've isolated something with your middle move. So now we look at, see what we did. Only these guys were affected. What happened is that this piece went to here, this piece went to here, and this one with the orange went to here. So now I have a way of 3-cycling these guys by that complexity of movement. Now the movement here is pretty simple, so to design an algorithm like that, it took a little bit of because of the simple movement, I had to kind of expand my commutator. So let's see if we get into muscle memory. Now it's also important to see the orientation. This green one started here, this just slid around to here. This orange one just slid around to here. So it's then this one went from here to here, because this orange one is over to here. So that's going to be important so that I understand the orientation of this. So let's do it again. To R, to U, to R, to U. I do this move here, so it's like the first, it's not really the middle move, but it's the middle move of the first part. Move this here, get it back with to U, to R, 2U, 2R, and now this comes back like so. Now this represents just the first part of the commutator. This next one is the middle move. This is isolated, move this like so, and now I reverse everything that I just did in the first part. I finished with the middle move, so I'm going to start, well, I keep calling this part the middle move. I finished with the first part of a middle move, now I'm going to start with it. So this comes up, then I restart that algorithm, 2R, 2U, 2R, 2U, move this again, and to U, 2R, 2U, 2R. And now this moves back. Okay, so now one more time, this should slide to here, this should slide to here, and this green all the way on this side should end up over here. So the first part of the commutator, 2R, 2U, 2R, 2U. Do what I thought was a middle move here, and then reverse it with 2U, 2R, 2U, 2R, and this moves back. Now what I thought was the end of that commutator really wasn't, so now this is the, almost in a fractile way, the middle move of the middle move. So bring this up, like so, then I move this here to reverse everything that I did. 2R, 2U, 2R, 2U. This comes up here, 2U, 2R, 2U, 2R. This moves back, and there you have it. So now I have a way of moving these around that I didn't use on this one because they didn't have the circles over here. So far so good. I'm finding ways of moving the outer shell without destroying the inner shell. So the fun part of complex puzzles like this is just playing around with it, seeing if you can find maneuvers like that. Now again, it's not to say that I'm just designing algorithm after algorithm. Algorithms are used only if I'm in a pinch, only if my intuitive way of solving is failing me, so that I just need to get pieces where I need to get pieces. So what else can I do? Well, I want to see if I can move these pieces around. I've got a lot of complexity here. I've got these middle pieces here, I've got this over here, and I've got these corner pieces, and then I've got all these pieces that I have to move as well. Now here's something that I suspect that I've seen with circle puzzles. Oftentimes with circle puzzles, there are certain pieces that never separate from each other. So although it seems like I have to put each one in individually, there may be some joining of pieces, outer shell pieces, with inner pieces. That if I put all the inner pieces in, the outers will simply fix itself. So I'm curious if something like that's going to happen, because the fact that this doesn't change means that scrambling the inner part and solving it's probably not much of a problem, because this really doesn't scramble. This only stays where it is. Even if I jumble it, this still stays exactly where it is. The only thing that doesn't seem to do that is possibly these guys. So I'm not going to worry about that yet. So in order to build more commutators, I need to do other moves. It's easy here, RU, RUI, FR, FIRI. So there's a lot of face turning moves that I could do. But what's an algorithm that I can use? A complex set of movements that I can do and then undo. Well, something that I've done here are double jumble maneuvers, or single jumble maneuvers. A double jumble maneuver is this goes up, this goes down, double turn, this goes down, this goes up. Then on the other side, this goes up, this goes down, double turn, down and up. So you can see that I did some flip-flopping here. These two flipped and these two flipped. So we can undo this, like so. So that's my double jumble maneuver, which is what I did when I wanted to swap corners. Now I did something similar with this guy. As you recall, this is equivalent to this move. So I went up, down, turn, down, up, and now on the other side, up, down, turn, and down and up. And then I take a look at what happened. Well, just like what happened with here, these two swapped and these two swapped, so too these two swapped and these two swapped. Now there's obviously more that's to it here, and I had to solve the corners, but in that way I was able to move these guys all around. Up, down, double turn, let's get it back before anything bad happens. Up, down, and double turn, down and up. Okay, so we can see what happens when you do something similar with this puzzle. So let's see what happens. We'll go up and down, double turn, down, up. I'm really enjoying the movement of this puzzle. It's very smooth. Up, down, double turn, down and up. Okay, so let's see what we did. We can see that this green went to here, and this black went to here, okay? And this went to here, and this went to here. So these moved as these moved. These pieces moved, which moved as these pieces moved. So that was expected. Now there's some complexity here because I see that these two also swapped. So this purple and green, which was here, went from here to here, and this purple and black went to here. So these swapped. And some middle pieces swapped too. This orange went to here, this yellow went to here, this black went to, this green went to here, and this black went to here. So within this corner, these guys swapped. So this isn't really much of a move by itself that I'm going to be able to use, but it could be the first part of a commutator. Could there be something of a middle move in here? Can I isolate any pieces? Well, let's see. I can always get this back by just doing my up, down, turn around kind of a thing, my double jumble maneuver, that's how I'll call it. But before I do that, is there a middle move? Well, if I were to move this piece up here, I'm isolating these two pieces. I just want to isolate one piece. If I isolate two and move it, it just gets too complicated. So notice none of these changed. And to get it back, all of these will get back to where they were. So what if I were to get this out of the way and put this in its place? So let's say I turn this like so, which puts this down here. So what if I do a 3 cycle actually of well, so what if I move this? I'm going to take this, move it down, and I'm going to take this, move it over here, and then take this and move it back. So here's what I did, and here's my thinking. If I can remember what I did, I don't want to get lost yet. So what I'm actually going to do is whatever's down here won't change at all. So I'm going to take this, bring it down, and whatever's here won't change at all either. I'm now going to take this, move this down over here. So I've kind of isolated this piece, like so. And now I'm going to move this back. So in that way, this piece was actually isolated. So let's see if that actually makes sense as I'm figuring this stuff out. I want to isolate this piece. This got moved. To isolate it, let's move this out of the way to move this here. Now now that this is isolated, move this whole thing like so with a 2U. So I did 2L, then 2U. Now I'm going to move this back with a 2L. In that way, this did not participate, only this did. So if I get it back, this will once again go down here, and this now will exchange over here, but this got replaced with this. So let's see what happens if I undo the commutator. Up, down, double turn, down, up, then up, down, double turn, down, up. Now I'm going to undo my middle move, and my middle move was 2L, 2U, 2L. So let's see what happened. This green went to here, this green went to here, this black went to here, and this, this green went to here, this peach, I guess, went to here, and this black went to here. So now I've got a nice commutator of these little pieces. So I can move these corners anywhere that I want, And these little outer central shell pieces anywhere that I want either. So in a pinch I can do that, and I used movements that are available to me, even though they're more complex movements, but they're movements nonetheless. So just to get into muscle memory, let's see if it works. So up, down, and turn, down, up, then up, down, double turn, and down and up. Now I got to do the middle move. That whole thing was like the RU, RUI, but I had to use this. To isolate this piece, get this out of the way, 2L. Now we move this, 2U, and now we move this back, 2L. Now we go up, down, double turn, down, up, up, down. I don't have to worry about the mess that this is looking like because I know it's all going to come back. Down, up, and now undo my middle move with a 2L, 2U, and 2L. So it did what I predicted. Now I predict this peach is going to go here, this black is going to go here, and this green is going to go here. So just so that I keep it in as I'm finishing my training with this, so to speak, up, down, now you see some snagging here, but that's just because of the complexity of the pieces. It does move smooth once they can get it lined up. Down, up, up, down, double turn, down, up. Let's do our middle move. Get this out of the way. Turn this here, and now we swap these guys back and everything should be fine. Up, down, turn it around, down, up, up, down, turn it around, down, up. Undo my middle move, 2L, 2U, 2L. Okay, so that's all there is to it. And that's the fun part of any new puzzle. You can use those commutators and just kind of have fun finding ways of moving things around the puzzle. So what else can I try? Well, I suspect that the middle part is going to be solved almost exactly like a curvicopter. So it's a curvicopter in the middle of a Rua puzzle. That's what I suspect. Now I didn't move these middle ones here, but I have a sneaking suspicion because I notice that when I make a move like this, these centers stay the same, and this stays the same. If I move this piece, this moves and this moves. I suspect that these edges will never move independently of these centers. So I can't think of any move. If I move this, well, this moves and this moves. If I move it here, this doesn't move and this doesn't move. And if I move it here, this moves and this moves. So my prediction is I don't have to worry about these guys. I think like with other circle cubes where things are stationary, this and this, once I move these in place, this will also move. What it also tells me is that I don't have equivalencies of these two pieces. They may be the same color, but because of these edges, it makes specificity of these two centers. So if these two are equivalent, whoops, to these two, these don't have specificity. There's equivalency between these two. However, there is not equivalency between these two because this edge and this edge is bounded to that. So, which is kind of cool. So given that, I think I have enough information that I need to intuit my way with a solve of the center the way I would solve a curvicopter, and then to utilize what I know about the solve of these corners here, and then using algorithms to solve these guys over here. So sometimes you have to just stop doing paralysis by analysis and just start to scramble the puzzle. Should I do more algorithms? I really can't think of any other movements that I could do. I know to do these guys. I know how to do an algorithm where I move this to here, and this to here. I'm not sure how it's going to affect these guys, but I know that to do what I want to do first is if I run into trouble with these while I'm solving the center, I know the double jumble maneuver will exchange this with this. These two will exchange and these two will exchange. Things are going to happen at the outer shell, but I don't worry about that because I now have ways of moving the outer shell independently of these guys without causing destruction here. So I may just move these into place initially, get the centers in, and then move everything else. But just so I know, what happens if I do my algorithm to move these guys? This to here, this to here, this to here. And the way that that worked is I did a 2F. Then if I wanted to go from up here, it's 2R, 2L, 2R, do another 2F, and reverse it with 2R, 2L, 2R. Okay, notice what happened is this orange, purple, and black did go here, so this went to here, this orange one went here, and this went here. And as I look at the center, I do see that this got offset. This went to here. This, where did you go? Went to here. And this went to here. So I caused a 3 cycling of these guys as well as it moved with it. So that what that tells me is that I'm probably going to want to move these outer shells in first before moving these in. Maybe. Okay, so with that said, I'm going to just go ahead and scramble. This will be a good opportunity to see how this puzzle moves. And then you can make the assessment if you think this should be mass-produced. From what I can see so far, this absolutely should be mass-produced. The design is really very tight. The design is very clean. Yeah, the movement is very smooth. And this is just with 3D printing. So imagine what it would be like if it's been moved, they use plastic molds with this. Okay. You know, I always like a puzzle that looks very impressive when it's scrambled. There's something about going from that degree of chaos and creating order out of it. The only thing is the stickers are very small and delicate, so oftentimes I've had to super glue them. Now, notice these guys can only do 180-degree rotations. So that's not going to be hard to place, I don't think. So let's keep scrambling. Okay, now what I'm going to do, now that I have this 180-degree scramble, is we're going to start doing jumbling moves. And here's what's going to happen. These pieces here stick to their orbits. As long as I'm doing 180-degree turns, they stick to their orbit. When I jumble them, if I single jumble like this and this, I'm going to swap these two orbits. These two are not in the same orbit, but if I swap them, if I do a single jumble maneuver, then I'll swap orbits. What that means is that although I can probably solve these and solve these just by placement, if I take these out of their orbits, it's going to cause some complexity. So let's go ahead and do that. Let me do a single jumble maneuver. And what orbits are going to swap? Well, I know that if I do a double jumble, these two will swap. So if I do a single jumble maneuver here, this will go here and this will go here. Make sure we're lined up here. Here, these two are going to swap. You're going to get some other motions. This doesn't change at all. These two, they'll swap with each other, but they won't swap orbits. This is the same orbit, but these two are not the same orbit. So just by going like this, I've now uncalibrated this puzzle. So that single jumble maneuver swaps these two orbits, and it takes these two and swaps these guys, and I guess these guys, but they don't swap orbits, but these two do. So let's go ahead and swap some more orbits just for the fun of it, because we want to enhance the challenge as much as we can to see how we get through this, see how we can intuit it. All right, one more swapping of orbits. Okay, now the most terrifying part, the jumbling part. Now I suspect that jumbling doesn't contribute too much to the solve strategy, but aside from just getting it hook back in. Move this here. Okay, so let's go ahead and start doing some jumbling. Move this like so. Move this here. And the thing about jumbling, eventually my movements are going to be blocked. Now I don't want to force anything. I don't want to do what's called fudging, which is forcing a move that I ought not do. So the puzzle will tell me when it's done being scrambled. Done being jumbled, rather. So already, here we go. So the centers, although they're turning, they're starting to look a little jumbled up, but don't worry. Don't panic. I'll maybe panic a little bit, because now these centers are scrambling, and I didn't know they could scramble quite like that. And I think once these centers are like this, it's going to be jumbled to the point that I can't scramble it anymore. All right. This is good here. This is good here. Is that it? Oh, there's this. There's this. There's this. Okay, how are we doing? Good enough? Okay, well, what do we think? Don't want it to let it be said that I was too easy on myself. Okay, well, there you have it. So a completely scrambled and jumbled circle face turning rhombic dodecahedron. And now the question is, because I honestly don't know as of yet, can the strategies that we used and can the perspective that we have of what kind of puzzle this is save the day and get us to the solve, and what kind of surprises can we expect? So that's what we're going to find out when I come back.